We have a problem not with structure, not with plumbing, not with electrical, with heating and air conditioning.
The builder was explaining to us that it was a new advanced system.
That was all we knew about it till we moved in and started operating it and realized it didn't work.
Now, the system that they put in here is a high velocity,
Yes.
2-inch line, right?
It's 2-inch duct line throughout the house. It's an insulated line, but it's done with hot water. So they're trying to be more energy efficient by using a hot water tank, supplying the hot water to the house, and with a forced air unit, blowing air over hot piping to heat your home.
I think what I need to do more than anything is first investigate, check out the system. Once I've opened up everything, I can see how it's been run. I don't want to knock the system, but obviously what they've done here is not working, and we'll find out why. We did the same tests, and we found within the whole house a wide variety of airflow per vent or per outlet. We do know why your air conditioner went, because it's a 3-ton unit. They put in a 5-ton cooling coil, which is an absolute no, and that just really smothered your air conditioner and burnt it out. Let's go into the garage. Within your ceiling, we have a cold air return hard duct here, and we have a cold air return right in the corner.
That goes down by the front door.
That's the damper.
Okay.
First and foremost, we do not want to put in an air return in your garage. That air return is pulling freezing cold air in. You might as well put a return pipe outside in the middle of winter pulling in cold air. When I'm done, you'll be comfortable, it'll be clean again, we'll move you back in.
Drywall, tapers, mud, gas line, you name it, everyone I know was in on this job.
At the end of it, we did our tests, and our tests showed that we were getting exactly what was supposed to come out of each register. We're actually lower CFMs, lower CFMs with a higher temperature. This is your 3-zoning system, okay? Every single line is insulated, taped, wrapped, airtight. Supply tank allows the supply of more water with a pump system to circulate it to keep it at that temperature to be more efficient and fire it through the house when you need it.
This is incredible. Just incredible.
A couple little things I'm seeing right off the bat. Very sloppy job, a lot of air leakage. See, what this does is it blows smoke. You can see all the air leakage you got here, all the smoke blowing out. And this is just in the furnace area. See, like the return air itself, you'll see it draw it in. So a lot of air leakage in around this furnace. Okay, we found a return air on the 2nd floor that was having an issue with not drawing enough air. And there's just a large cavity that was drywalled in the front here. We removed the drywall. Problem is, this void is just too big. You got a lot of air leakage that the cavities, you know, they nail in the wood, a lot of air leakage in between. A furnace can only deliver as much air as it's supplied. Since we're not getting much air from the 2nd floor return, it's causing poor circulation up in those floors. This being a cold garage, no insulation on this wall. One, it's taking the cold right through into that return. I've noticed right here through the brickwork, this is open from the garage into this return. If they park this car in the garage and they have it started wintertime, it's gonna suck the fumes from the car into this opening and draw it back throughout the whole house. So this is an issue, we have to address it. At this point, it's just running a ductwork from here all the way up to the joist cavities above and running it all up to tie in our return. Once they spray foam around this, it'll be insulated, and we'll be drawing actually just from the cavity up on the 2nd floor. So once we start sealing up that ductwork, sealing up our supply, sealing up our return, I want to increase our air volume, our CFMs, and I'm hoping to drop my temperature. Right now I got a lot of air, just my temperature is really high. So we're going to try to improve on that.
We had Gary come in, do a CFM test, cubic feet per minute, so we're looking for velocity and airflow. He tested this specific register. He had 480 on the CFMs, and he had a temperature of 25 degrees Celsius. So since then, we have insulated underneath, completely re-drywalled, and he has taped all the main trunk downstairs so we don't have any air leakage. So what I'm doing
because I'm just going to run my tester over top of it to see the difference. 671. Look at the temperature, 17.8. So that's about a 30% improvement to the temperature and about 40% more airflow. That's a huge difference. The furnace no longer has to work as hard to cool or even heat this house. Man, that's money in the bank.
Now that everything's sealed in the garage, I'm not going to have any of that carbon monoxide coming in anymore. It's just going to be nice, clean air.
I like what Gary did. He first did an air test with CFM, the little toys that we had, the meters. He did his smoke test around the furnace. Major bleeding of air coming off your furnace and the main trunk line. Since then, we have taped everything up, siliconed the furnace. By doing all this, what you're actually going to do is now use your furnace at full efficiency. You're going to save money, have more airflow. You're going to be cooler in the summer and hotter in the winter.
I'm feeling much cooler right now in this house. That's making me feel pretty good. With the air conditioning on, which isn't even running right now, and it's just steady temperature. I can tell you before, that air conditioner never turned off.
We started to smell damp, wet soil. It wasn't moldy or musty or anything. It was just it smelled like outdoor.
And that's when we realized that the ductwork actually was made out of a cardboard tube, and when I reached down to find out what was happening, a little hole in the cardboard appeared, and then there was gravel beneath it. The tubing that was coming out of the wall in the furnace room that we had thought was just cardboard insulation actually was indeed just the duct, and it was just made of cardboard.
Okay. This is the sonotube they're talking about? It is sonotube.
One of the two, yes.
It's never going to work. Think of the moisture in the ground. It's going to rot out the galvanized. It's going to rot out the cardboard paper that a sonotube is. Extremely hard cardboard paper, meant for concrete, but not for ductwork. Here's what I see. The sonotube is right here in the floor. It has deteriorated, obviously, from water that touches this area. And everything was run through this line.
For the lower level, it's run through this line.
And the upper?
And the upper level is through the bulkhead here.
Okay. But I'm going to be ripping things open left, right, and center throughout this house to run new trunk lines, to run new duct lines. Running the ductwork this way is just the most ridiculous thing I've ever seen. We're going to close off all ports. This is not the way to do this. Had they have done this right, I probably wouldn't be here.
Well, this is sort of like putting the final nail in the coffin of the old HVAC. Existing gaps where the sonotubes were, where the vents came out of the floor, basically you have holes in your concrete. We got to fill the holes so that they can peel this off and get their hardwood, their tiles, whatever they want to put down here at the finish. Also stops bugs from coming in, which everyone will be happy about, mice, and the smell of wet earth. We've helped them with their HVAC system. That was a big one. Everything was running underground, rotting. They weren't getting their proper ventilation everywhere. We gave them back their heat and proper ventilation. Now they can do what they want to with this house.
Look at your ductwork.
Yeah, it looks
It's
a lot
almost
different.
pretty.
Yeah, it was a big difference. Huge.
Because we literally ripped your house apart is what we did. And as we walk through, I'll show you. But all holes cemented in, all the walls cemented in, so that is all back to where it's supposed to be, underneath the concrete, and no longer part of the environment of the house. I'm happy with it.
It's like winning a jackpot that you can't show anyone. It's all behind the walls.
Yeah.
I mean, it's more than ever we expected. But everything that's there now works the way it should.
Usually when I'm called into a job, it's bad electrical, bad plumbing, structure, you name it. But what made this job different was geothermal cooling and heating technology. This is a new system. I want to know if permits were pulled. The average temperature of the Earth is around 14 degrees Celsius. We have vertical loops that go into the ground. We're running liquids through those pipes that become that temperature. We bring them into the house, into that geothermal unit. We can now heat and cool the home efficiently. I'm bringing in the geothermal guys.
Yeah.
So what we want to do is find out where the hell they dug the wells. We're gonna have to talk to them first, because I don't want to just dig blindly and,
Right.
and, you know, hey, look, we found worms.
Yeah.
Geo-Thermal systems, the way that you really benchmark the piece of equipment is based on what's going on in the actual loop itself. So what we need to be able to do is actually take a pressure temperature reading right here on the equipment.
Yeah.
And what you would typically find is a Pete Sport, and that will tell us whether this piece of equipment is operating correctly. And internally, there's just issues everywhere. Simple little things like, when you look at where the flow center is connected here, you can see we've got solid connections. But yet when we look at the return one, we've got silliness like we've got this red tubing, right? This should be a straight connection going out all the way through. And for some reason, they've decided they wanted to put in some red garden hose. I mean, the equipment may run, but that doesn't mean anything. It's like an air conditioner. You can have an air conditioner that runs. If it doesn't cool the air, who cares?
Right.
You know, we really need to get to the bottom of
Well, it
this.
sounds like it's working, right?
Yeah, well, you can hear it running. Yeah, if the fan's turning, that doesn't mean it's working.
Okay, so you're going to go through this, and then you're going to tell me what you find. And I already know we're taking it out, but I'm really curious to see what they've done wrong.
Right.
Everything we've seen so far is a little messed up, isn't it?
One thing that was, I think, of real concern is the fact that the lines were buried so shallow.
What are we at, about a foot and a half here?
Yeah, generally we looked at the whole site, and that's about what everything was buried at. It's just about 1 foot below ground level, which kind of sends up some red flags. The other thing that's of real concern is that all of this is right in the tree roots. Anytime anyone ever does anything on this property, if they go to dig in another tree or a shrub, or if there's any utilities,
Good point.
they'll be right into these lines.
Which what you're saying is I don't think you want to attach to this.
No, I think we've seen enough to know that we're probably uncomfortable with doing that.
I think that's the best call. So now that we've decided that the loop field is not reusable, the geothermal guys can fuse the old lines together to make sure nothing leaches back into the ground.
Another thing too is maybe just grab onto that line right there, Damon.
Oh, is that ever hot?
Right, and that, this machine hasn't run for several days.
Good point.
And yet you can feel how hot those lines are. So this heat is actually convecting from the electric water heater that this is attached to. So that could explain some of the high utility bills that they have, because actually it's taking heat from the hot water heater and running it the opposite way.
Instead of using the geothermal, it's actually running off that.
Right, yeah.
So really busy day today. We have the new geothermal unit here, which means we can put the house back together, get the homeowners back home.
Well, the piping that we're putting in now, we're just making sure that the pressure drop is minimal, trying to keep as few 90-degree elbows as possible between here and outside. And yeah, making sure too that it's properly insulated and that all the tail ends of the insulation are properly sealed, so there's no chance of any condensation happening and coming down through the finished ceiling when that's all said and done.
Now, a rotary drill is used to bore into the ground 10 feet at a time. Water is then fed down the center of the pipe, and this forces the earth from the hole up to the surface.
So as soon as we complete drilling each hole, we have to pull all our rods out one at a time, and then we go ahead and we put our loop down the hole. It's lowered down with a winch cable, drops the loop to the bottom of the hole, and then we basically just pull that back out with the winch, leave the loop in the ground, and then onto the grouting.
Today we're going to dig up all of the vertical bores, and then we're going to bring them back and manifold them all together, which will distribute the water solution throughout all of the pipes equally. We will need to fuse all of these into this manifold here, and then from there we'll put some pressure on it, make sure it's good. We'll hook a compressor up at the machine and pressure it all up, and then we'll backfill once we've tested it.
Big day today. The geothermal is actually done in the yard. We have Rob from Buchanan and Hall today actually coming to turn it on. I just want to know a couple of the differences between what was here, what was stuffed under that crawl space, and what the new unit's doing for us.
One of the major complaints was in regards to the noise, and when we did run that unit, there was a lot of noise and vibration that came from that, and that resonated right up through the floor and into their living room.
Right.
As you can hear, this one is running
quiet
right now.
Yeah.
And that's running full out, and we're able to have a conversation, and it's, you know, it's almost about as quiet as a good quality refrigerator. There's diagnostic lights that are right on the front of the machine down here, and those lights read, again, if there is a fault, it will read here, but it will also read what that fault is up on the thermostat, and it'll store that there. If it's done properly, I mean, they're a great system.
We got to talk a little bit about what we found. You already knew the last time I brought you here that the Geo-Thermal was just below grade. So we went 6 holes, 135 feet deep. We did a whole new vertical loop system in your front yard, fixed it all up, and you can't even tell we were here. Like, we had to come through the wall with how many runs? 6 runs.
6 runs altogether came through that wall.
Whoa.
So just above this is where we had to feed. There's a room above, so we have to get your basic heat runs to the front of the windows. It took a lot of work.
It's beautiful. It's just
already?
Unbelievable. Yes, yes. I'm so happy already.
You remember when I first brought you in, the Geo-Thermal went out the wall right here. It was 6 inches beneath the earth, right?
Yeah.
It now goes out the wall down here. So it's the way it's supposed to be because we brought in all the right people. We took out of the crawl space that unit that was there. We put in state-of-the-art. This is a beautiful system, and you can see how professionally it's installed.
Oh, yeah. I think it's a great idea that everything was moved from the crawl space and put here. I think it's a much easier access and
very easy to use as well.
Yes.
By the way.
What I love about this system is that we are taking Earth's natural temperature and we're raising it by a couple of degrees, putting it throughout your house, so it doesn't cost a lot to do it. At the same time, as we're heating to 140, we'll put it into a holding tank. Now, this holding tank, instead of wasting it, because we are cycling, think about how that water goes, this now assists your hot water tank.
It's no matter what they promise to do, they will always deliver. And that's what they say. You are the most lucky people, because that's Mike Holmes with his team fixing the house. And this is things that no money can buy.
Are you happy?
Yes, yes, I'm more than happy. Come on, it's
then I'm
like,
happy.
Yes,
then I think we did our job right.
Thank you very much.
My pleasure.
Thank you.